Hello, it's Dumplet here. Welcome to a collaboration project between Dumplet and Cedie's Mathverse on Hong Kong International Math Olympiad questions. For this one, Andy randomly picks answers in a multiple choice test. The test has 10 items with 4 choices each, and each question has 1 correct answer. Find the probability that he gets exactly 7 correct answers. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Now, the only condition given to us is that Andy wants 7 correct answers, but we can easily infer from that, well, if there are 7 correct answers and there are 10 items in total, well, Andy should get 3 items wrong. Now, we're going to use the concept of binomial distribution, and I've covered this topic in the past. You can click this card above here. You can watch that video, but practically the solutions will just be the same anyway. So we have 7 correct answers and 3 wrong answers. So let's just write it down for now. So 7 C's and 3 W's for correct and wrong. Now, note that we can take the permutations of any arrangement, so any arrangement of C's and W's, and we'll have 10 choose 7 or 10 choose 3. Well, both will be the same. So it doesn't really matter whichever you choose, but in total we'll have 10 choose 7 or 10 choose 3 ways to arrange 7 C's and 3 W's in a line, but just refer to it as somewhat like the order of the questions, or like which items did Andy get wrong and which items did Andy get correct. But all in all, there are 10 choose 7 or 10 choose 3 ways to arrange those, and we have the corresponding probabilities for each correct answer to be 1/4, because there's only one answer in every 4. There's one answer out of the 4 choices, and obviously if it's not correct, it's going to be wrong. So we'll have 3 out of 4 choices to be wrong. Now, combining those facts, we're technically arranging the C's and W's. So we have 10 choose 7 or 10 choose 3, but for demonstration purposes, I'll just use the 10 choose 7. So the first factor here of 10 choose 7, it's the arrangements of C's and W's. The second factor here of 1/4 raised to 7, that corresponds to all the C's. So it doesn't really matter where the C's are placed or arranged. We know that there are 7 1 raised to 4s. So that's 1 raised to 4 times 1 raised to 4 and so on 7 times. So that's just 1 raised to 4 raised to 7. And same logic for the 3/4 cube, because we have 3 W's, and whatever the arrangement, there are 3 3/4, so 3/4 times 3/4 times 3/4, so that's 3/4 cube. So if we evaluate this will be the binomial coefficient of, or something like similar to the binomial expansion. So all you have to do is just evaluate that. So 10 choose 7, you can use whatever formula you like. You're going to get that it's going to be 120. And for the 1/4 raised to 7 times 3/4 cubed, well, we know that 1/4 raised to 7 is just 1 raised to 7 over 4 raised to 7, and 3/4 cube is 3 cube over 4 cube. So the numerator we should have 3 cube. In the denominator, we should have 4 raised to 7 times 4 raised to 3, so that's just 4 raised to 10. So all we're left to do is just simplify this result. So after some simplification, we can probably write 120 as 15 times 2 cubed, and write 4 raised to 10 as 2 raised to 20, so you can easily cancel the 2 cubes, and then all we have to do is just 15 times 27 divided by 2 raised to 17, and just simplify. 15 times 27, that gives 405. 2 raised to 17, that's pretty big, but we're going to get that it's 131,072. So for our final answer, we have 405 over 131,072, and this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.